Hi, you're watching the Factoring Out the Greatest Common Factor Notes video. In this video, you're first going to understand what a factor is, and then we are going to find and factor out the greatest common factor. So we'll identify what it is, and then we'll factor it out. So this is the first lesson where we're going to talk about factoring. So we're kind of switching gears now, and we are going to undo everything that we've been doing, if that makes any sense. And you probably will understand that a little bit better when we get to the end of the video. But first, in part 1, it says to find the missing factor. So 4x squared times what would give us 28x to the 4th? Well, 4 times 7 will give us 28, and x squared times x squared will give us x to the 4th. So the missing factor was 7x squared. All right, let's do the same thing here. What times 3x cubed will give us negative 30x to the 7th? Well, negative 10 times 3 is negative 30, and x to the what? Well, 7, 6, 5, 4, because when we multiply, when we have the same base, we add the power, so 4 plus 3 is 7. So the missing factor was negative 10x to the 4th. All right, so now we're going to dive into the greatest common factor. It's the common factor of 2 or more whole numbers. Okay, and it divides evenly into each of the terms. So we can find the greatest common factor of numbers and variables, or a combination of both. So if you think about 18 and 27, the factors of 18 are 1, 2, 3, not 4, not 5, 6, not 7, not 8, 9, and 18. Right? All of those numbers divide evenly into 18. Same thing with 27. So 1, well, not 2, 3, not 4, 5, 6, not 7, not 8, 9, I think all the way up to 27. So not a ton of factors of 27. If we are looking for the greatest factor that they share, well, the greatest factor that they share is 9. If we look at example number 4, well, we are going to do the same thing, only we are going to find the greatest common factor of 4 and 12. We don't usually take into consideration the negatives when we're dealing with GCF. So what number can divide evenly into both 4 and 12? Well, that's 4. And look at both terms have an x. So this means 4x is a GCF, because we could divide out a 4 and an x out of both of those terms. Okay, so when we are factoring, we're just doing the opposite of distribution. So let's just review distributing, because we've done this before. So 2x all times x minus 4, that whole quantity, is 2x squared, because remember that big rule, x times x is x squared, minus 8x. When we factor, we actually start with this. You see that there? So what we're going to try to do is find what is a GCF of 2 and 8. Well, 2 is the biggest number that divides evenly into 2 and 8, and I can't take more than just a plain old x out, because if I do, this term here won't have another x to give. So I can factor out a 2x, but I'd be left with, well, 2 divided by 2 is 1, and x squared, if I took out an x, is plain old x. And then same thing here. Negative x divided by 2 is negative 4, and if I divide this x out of that x, I don't have any x terms. So it's the opposite of what we do when we distribute. Let's see this in action again. So when we distribute, it's going to look like this. 3x squared minus 6x plus 3. But in a factoring question, we actually start with this, and this should actually be a 3 here. Okay, so 3x squared minus 6x plus 3. So what number divides evenly into 3, 6, and 3? That's 3. And then can I factor out any x's? No, because this last term here doesn't have an x. This has an x, this has an x, but they all have to have an x. Remember, greatest common factor. So 3 times what will give us 3x squared? X squared. 3 times what would give us minus 6x? Minus 2x. 3 times what will give us plus 3? A positive 1. This is the process of factoring out the GCF. Okay, so one thing to keep in mind is that when you're factoring, you're just rewriting it. So let's practice a little bit more factoring out the GCF, okay, down below here on 5 through 8. So what number is common to both 8 and 10? What number can divide evenly into both 8 and 10? If you said 2, you are correct. So what is left over when we pull out a 2 out of both terms? Divide out the 2. Well, 2 times 4x would give us the 8x. 2 times minus 5 will give us a minus 10. This is a factored form. Okay, I'm going to do number 7 next. Okay, so what number is common to 18, 9, and 6? What number can divide evenly into 18, 9, and 6? What is the biggest one? If you said 3, you are correct. Notice how not all of my terms have C's, so I can't have a GCF of 3C. So this just becomes, well, 3 times 6 will give us the 18, so 3 times 6C squared is my first term, and then 3 times negative 3C will give us that negative 9C, and plus 2. We can always tell that we factored out the GCF if all of the terms in here don't have anything common, and 6, 3, and 2 don't have a common factor, and not all have a variable. Okay, number 6. At first glance, some people might say, oh, this is just 1 and not, and so the GCF is 1. Well, it can be a number and it can be a variable. So, or it could be both. So let's see. They don't have really a number in common. We don't ever really factor out a 1. It's kind of pointless. But do they have variables in common? The answer is yes. They have an x that they could both factor out. So x times x would give us x squared, and x times negative 9 would give us minus 9x. Okay? And last but certainly not least, question number 8. What number is common? What is a common factor of 6 and 12? If you said 6, you're a rock star. Do both of our terms have variables? They sure do. But we can, remember, only pull out the smallest one out of all of them. When we do that, 6x times x would give us 6x squared. You could also write 1x in there. I'm cool with that. And then 6 times 2 would give us 12, and x times, well, there can't be another x there because then that would have made it x squared. So we could either write this as 6 all times 1x plus 2, or 6x all times x plus 2.